Hi everyone, my name is Tom Dean and I'm a product manager here at Cloudera. And today I'm excited to tell you everything about CDP Private Cloud Data Services. This is our latest data analytics product designed for the data center. We'll go through a demo, but right before that, I'd like to spend just a couple of minutes setting the context for this product. If you've been following Cloudera for some time, you know that many of our customers started their journey with us with the traditional co-located architecture. And what I mean by this is that both compute and storage processes ran co-located in the same infrastructure. Now, this was a great way to save on costs, especially when networking wasn't very fast. But over time, these clusters got more and more complex to manage. So for the past few years, we've been in a journey to transform this architecture to a more flexible, agile, and easier to use product. And that's what we call CDP Private Cloud. CDP Private Cloud is made up of two major components. At the top, we have the data services. These are a set of containerized analytic applications that cover a wide variety of use cases and workloads, from data flow, data engineering, data warehousing, operational databases, and machine learning. And then on the bottom half, we have our base cluster. These are the stateful services that all the data services connect to get access to the metadata for table schemas, security policies stored in Ranger, governance with Atlas, and finally our storage systems, where we have both HDFS as our traditional file store, as well as object store, as an object store powered by Apache Ozone. Now, this same architecture that we offer in the private cloud, we also offer in the public cloud. And this is really the key enabler to hybrid types of deployments. By offering the same UIs, the same user interfaces, the same APIs and CLIs, we can facilitate the movement of workloads from AWS, Azure, and Google to and from on-prem environments. We also have tools like Replication Manager that facilitate the movement of data across these different environments. So let me tell you a little bit about this product, CDP Private Cloud Data Services, and what we offer as of last month. So what is the previous version? That was version 1.2, and in this version, we offer two services. We had data warehousing and machine learning. The other requirement with Data Services 1.2 is that we asked our customers to provide us with a dedicated Red Hat OpenShift cluster that was configured exclusively for CDP. Now we have an exciting announcement, which is the release of Private Cloud 1.3, Data Services 1.3. This will be generally available this month in October, and there's two big components that make up this release. The first one is the introduction of Cloudera Data Engineering. With Cloudera Data Engineering, our customers will be able to build complex ETL pipelines that are orchestrated by Airflow. This will all be powered by Spark on Kubernetes, and they'll be able to schedule, track, and optimize job performance. But more importantly, this completes a set of workflows that will allow customers to build these multidisciplinary workflows across data engineering, data warehousing, and machine learning. The second big component of Private Cloud 1.3 is the introduction of the Embedded Container Service, or ECS. For customers that don't have OpenShift or don't want to worry about learning a new tool and deploying it and managing it, the ECS provides a complete out-of-the-box experience where everything is included and automated in order to run data services. So customers will be able to deploy these data services straight onto bare metal or virtual machines without having to worry about these additional complexities. You will also have integrated monitoring and security, and only one vendor to deal with for support cases. Okay, and with that, now let's walk into the demo of Data Services 1.3. I will show you in this demo, we'll start with the base component and show you how we connect to those. Then we will go into each one of these three data services, DE, DW, and ML. and show you how the embedded container service works at the end. Okay, so what you see here is our homepage for CDP Private Cloud experiences. You see the word experiences here, and the reason for that is that we have recently changed the name to CDP Private Cloud Data Services, but it's going to take us one more release before you see all those name changes come through the user interfaces. So when I say when you see the word experiences, just know that that's referring to the data services. Now, we'll walk in through each one of these services, but before we do that, let me start with the management console. This is the central panel where your administrators will be monitoring the health of the platform, their resource utilization, setting access controls, role-based access controls and permissions for any user that's interacting with the platform. But one particular area that I wanted to show you today is the concept of environments. And what you see here is that I have created a default environment. And what the environment is a collection of pointers to the stateful elements. And these include the Hive Metastore for table schema, Ranger for data access policies, Atlas for governance, and finally the storage system, so HDFS and our object store Ozone. Once you have this environment created, any compute applications that we deployed inside of the default environment will get automatic access and integrations to all these stateful elements. So it only needs to happen once. All right, now that you have the environment set up, let's go back to the data services. Okay, for each one of these data services, we could easily spend an hour going through each one of them. But instead of doing that, what I'll do in this particular demo is just show you how each one of them provides ease of use, elasticity, and isolation. So three characteristics that are prevalent across these data services. And I will show you just one example of how each one of them provide these values. So we'll start with machine learning, then move on to data engineering, and finally, we'll finish with data warehouse. So here I'm clicking inside machine learning. This is our collaborative data science tools where data scientists come together and run exploratory data science. They do predictive modeling and schedule and run jobs. So for this example, I'm going to show you creating a new project. We're going to use a template. And I'm going to show you how easy it is to start a new session. So we'll give it a name. And here you start to see the elasticity aspect. As part of creating this session, I specify how many cores and memory I need for this particular session. I'll click Start Session. And what's happening now is that we're scheduling a container on this shared Kubernetes environment where I can have all my libraries in isolation of anybody else's software libraries. So in just a few seconds, my environment is ready to go, and I can start running my R analysis, as you can see in this example. So this gives you a quick glimpse of those 3 points, right? My container environment here is fully isolated from anybody else's. It took me just a couple of seconds to be running productive work inside of this machine learning product. And I'm able to scale up and down based on the resources that I need at this time. Okay, so that gives you a quick glimpse of machine learning. Let's go back and now show you the data engineering product. Okay, so we're clicking into data engineering. And here the top level of isolation is called the virtual clusters. So the virtual cluster specifies a particular Spark version, Airflow version, a number of services that you would like to keep isolated from other clusters that may be running different versions. Inside of these virtual clusters, we'll be able to schedule complex ETL pipelines with Airflow. But for this particular example, I'm just going to show you a simple job. So to create a job, we'll go to the job screens and create job. We'll give it a name. And in this particular job, what I will do is I will run a Spark job using PySpark that reads data from HDFS and writes it into a Hive table. I will then be able to use Cloudera Data Warehouse to read from that Hive table. So this is some retail data that we have on HDFS. You can either upload a file or select a resource if you have already pre-uploaded a file. Okay, so I have selected a file. Now here you can click on Advanced Options, and it gives you, back to the elasticity point, it gives you the chance to specify the minimum and maximum number of executors, as well as how many cores would you like to have per executor and how much memory you like to have per executor. So you can play around with this based on the demands of your particular job. You can also create schedules and specify advanced settings. So now that I've created the job, I will go ahead and run it at this time. So you can see the job has been initiated. And again, just touching a couple points here, this job will be isolated from any other jobs. It has its own Spark version. It just took me just a couple of seconds to create it and run it. And I specified all the auto scaling settings so that I only use what I need at the time I need it. So all 3 points are covered here with data engineering. So I'll go to job runs, and you see the job is currently running. I'll go to view more details. And you can see here in the log files that it's kicking off a Spark on Kubernetes job. It's going to read from HDFS and then eventually write the data. Okay, so while the job is running, I'd like to show you Cloudera Data Warehouse. So let's go there. And here, this is where our BI analysts will have their isolated SQL environments inside of what we call virtual warehouses. Creating a virtual warehouse is a very simple process. The first step is you give it a name, and then you pick the underlying engine, Hive, LLAP, or Impala. You pick a t-shirt size for the warehouse, and then you have a number of auto-scaling settings where you can specify the minimum and maximum number of executors. You can also specify how long to wait before we scale up and down. Once you've done this, you click create, and it takes just a couple of minutes to have a new environment. Now, before this, I actually did create a virtual warehouse that we can use for showing you in this demo in the meantime. So let me cancel this one. And what I like to do is open the SQL editor, which is Hue. Now here we are in Hue. And what I like to do now is run a SQL query that reads data from that Hive table that just got created by the Spark job running in Cloudera Data Engineering. So that's the retail table here, and I'll hit the run button. And as you can see, I just got these results back. So this shows you the power of SDX, the shared data experience. I started a job in one data service, and all that data, the security policies, the governance, that's all shared with Cloudera Data Warehouse. So I'm able to start doing work on this other service without any more further integration. Okay, now let's go back to the home page. And I've now shown you each one of the data services. And the last piece that I'd like to show you now is how easy it is to get started with this setup. And to do that, I will go to Cloudera Manager and show you this new ECS, product, or the embedded container service, and how easy it is to get started. So here I'm logging into Cloudera Manager. Let me just go back to the home page here in Cloudera Manager. As As you can see here, I have a regular cluster with all the services, the stateful services. This is where many of our customers are today, running with these kinds of services in running on bare metal. But now let's say they want to attach a set of the data services running on containers so that they can talk to the HDFS, Hive, Ranger, and these services living in the base cluster with a separated compute and storage architecture. You click on experiences, which will be renamed to data services. You click on add cluster. We have two installation methods. You can do it either directly from the internet or air-gapped. Just for this example, we'll do internet. Then you give the cluster a name. So in this example, let's just call it compute cluster. And you set the base cluster where we're going to connect that compute cluster to by default. So we'll automatically create that environment that I showed you earlier for you. And the last step here that I'll show in this particular demo is just specifying the host. So this is where you specify the virtual machines or bare metal IP addresses where we're going to deploy ECS and all the dependencies that you need to run all the data services. All of that will be automated for you, so there's no need to worry about learning or managing these additional platforms. Okay, so let's go back. Once you're done with this process, you'll get this homepage and you'll be able to start running workloads. All right, so with that, we wrap up the demo. To summarize, we've shown you the new data services running on the embedded container services. That includes Cloudera Data Warehouse, machine learning, and data engineering. We show you how easy it is to set them up, how you get isolation across multiple tenants, and the elasticity aspects of all three data services. And with that, we wrap up the demo. Thank you for watching.